everyone, I am Aman and you are watching your favorite channel Aman Teen Excellence. Today we are going to study about Eureka can density of liquids, floating and sinking. I have made previously two parts of this video and have dropped the link in description box. So let's start about this video. Please like, share, comment and subscribe my video. So first, we will study about Eureka can. The Eureka can is the container which measures the density of the solids that are irregular or regular. And we can use a graduated beaker also, but if we have to measure the relatively big stones, like big stones or big solids, relatively big solids, so we can use Eureka can. It is the metal can which is having the long tapering out, and this is a Eureka can. As you can see, there is a spout, there is a long tapering out of this Eureka can. Now, how to measure the liquid how to measure the solid by the help of Eureka can? We can measure the solid by the process. That is, first we will take the liquid in the Eureka can and fill it till its brim, and then the water will flow. We can collect it or we can get it to flow. When the water stops to flow, we can drop our solid very carefully that don't touch the sides of the Eureka can or the bottom of the Eureka can, because it can inaccurate the measuring. Then the water that comes out, we can measure it by the beaker or the graduated beaker. Now we will study about density of liquids. What is the density of liquids? The density of liquids is the mass upon volume is equals to density of liquids, or is equals to density of solid or anything. But how to measure the density of liquid? We have learned about how to measure the density of solids in the previous two videos. Now we will learn about how to find the density of a liquid. So how we find? We have to take graduated beaker. First, we have to take a graduated beaker and take 60 ml or 70 ml, as we can take any volume that is easy to measure. Okay, if we take 100 ml, then how we can measure it? We can measure it by the balance, electronic balance or anything. First we have to measure the beaker with the water. Okay, then we have to measure only the dry beaker in which we have taken the water. So if we will difference it, then the volume of the water will come out, and then we will divide it by the volume. Now we have to study floating and sinking. Floating and sinking is the phenomenon that we have already observed in our teenage or in kids. As we have noticed, some of the objects float on water and some of the objects sink in water. As if we take one metal, plastic and wood, paper, so we will observe that wood and paper and plastic, these three will float, but the metal will sink in the water. But why? Because the density of the water is less than density of metals, but the density of plastic, wood, paper is less than water, so they float and the metals sink. This is observed by the principle that is also known as Archimedes principle. Archimedes is the ancient scientist of the ancient times. He noticed and tells about force of buoyancy. What is the force of buoyancy? It is the force in water or any liquid that pushes the thing that comes in the water. If the force of buoyancy is more than the density of the solid or anything, then the solid will float. But if it is less than, then it will sink. But if the force of buoyancy is equal to the solid density, then what will happen? It will float. As if we take, it isn't it that only in water the force of buoyancy applies. It also in the air. As if we take hydrogen gas balloon, it will float, means it will rise up and up in the air. If we take carbon dioxide balloon, it will go down and down. But if we take the balloon which is filled by the air, when we will leave the balloon, it will on the same position. It will neither go up nor down. And if you have some problems, tell me in comment box, and in next video we will solve numerical problems related to this, and there is something to know fact which I will tell you in next video. तब तक के लिए goodbye.